All right, thanks everybody for joining today. We have another talk from the great team at the University of Michigan. This is a continuation to a certain extent of the talk that occurred last week, where we're going to be going into a little bit more detail about some of the specific software projects that they were working on this summer. And it's going to be focusing mainly on perfSONAR plugins. And I think there's around maybe 8 or so that are going to be highlighted, and they're going to be presented by each of the different speakers. But I'm going to throw it over to Mark Feit from Internet 2 first, just to kick us off and give us a little bit of top level, and then we will get into the individual presentations. So Mark, if you want to take it away.
Thanks, Jason. Hi, everybody. I'm Mark Feit from Internet 2, also of the perfSONAR development team. As Jason alluded to, if you were here last week, we talked a little bit about the methods that were used to develop the plugins that we're going to talk about today. So without further ado, I think I will throw this over to Frank and let him kick it off.
Yep, thanks, Mark. Hi, everyone. My name's Frank. I'm here with Ali, Alyssa, Samuel, Maxwell, Yihua, Daniel, and Jing. And we're all currently interns at the University of Michigan. Today, we'll be presenting about the plugins that we've worked on this summer for perfSONAR. Also, if you have questions during the presentation, feel free to leave them in the chat. So before we dive into the plugins themselves, I'd like to briefly go over what perfSONAR is again. So perfSONAR is an open source network benchmarking toolkit, and it gathers measurements about the network through plugins, which are either tests or tools you can see down here. And the main component of perfSONAR is this middle block called pScheduler, and pScheduler will determine when things will run, and it'll also report results. So pScheduler will interact with tests. Tests then use tools to get the measurements. Results are returned to the tests for formatting, and then back to pScheduler. So I just want to make it doubly clear the difference between tests and tools. So tests don't do the measurements themselves. What they'll do is they'll define the measurement and the result. In other words, they define what options or arguments are taken in. Then they'll format these and then give them to the tools. The tools will take this standardized input and then run the measurement, produce a result, and then gives that to the test. The test will then format the results and then give it back to pScheduler. There are also archivers in perfSONAR. None of the work we did this summer had anything to do with archivers though, so we won't be mentioning them. So as a brief overview, this summer, the 8 of us have created 6 new tests, 8 new tools, and we've also enhanced 1 test. And with that being said, we'll go into more depth about each of the plugins we made, and each one of us will be presenting the plugins that we made, and I'll get us started. So the first plugin that I made was the MTU plugin. The test is called MTU, and the tool is called FWMTU. And for those of you who don't know, MTU stands for Maximum Transmission Unit. And it's basically the largest packet size that can be sent over the internet. And this is useful to know because it could help troubleshoot if no data seems to be being sent. A common scenario is control packets are sent, and these control packets are small, and they're used to see if the destination is reachable at all. And because they're small, they'll probably fit within the MTU. But then once you start sending larger data packets, those might be larger than the MTU, and they won't get sent. So the test takes 2 very important arguments, of course, the destination, and optionally you can specify the port. If you don't specify it, it'll default to 1060, which is the default UDP and TCP receiving port. And you can see the code on the right. The way it works is it basically just uses this IP MTU discover in Python, which tells Linux to use the discover MTU option, which will just find the MTU. And here you can see a sample run of the MTU plugin. You can see the command I ran up here has the destination, which is umich.edu, as well as the port. And after it runs, the only thing it returns is the MTU. In this case, it's 1500. This is in bytes, which is a pretty standard MTU. And the next plugin that I made was the Halfping tool. And this is associated with an existing test, which is called Latency. And what halfping does is it will measure the approximate latency by pinging the destination, getting the round trip time, and then cutting that in half and saying that's basically the one-way time. Just to note, this is an approximation because sometimes going from the source to the destination can take longer than coming from the destination to the source or vice versa. But this can be useful if you want to measure latency to a device without OWAMP or TWAMP. And these two are the standard latency protocols. So if the device on the other side doesn't have OWAMP or TWAMP, then you can't use them. So you can use halfping to approximate latency. So the latency test does also have a few options that ping can't handle. So they're disallowed in the halfping tool. And you can see the code on the right. The important thing is, of course, this thing circled in red, which just takes the round trip time, cuts it in half, and says that's the latency. And here's a sample run. You can see what I ran in this box up here. Here I specified the halfping tool. In this case, you have to specify the halfping tool because it has low priority. By default, if you run latency, it'll try to use OWAMP or TWAMP first. But I just wanted to show the results for halfping here. So that's why I specified it here. And I also have the destination and a few other options. And you can see the output here. And this is all formatted by the latency test. So this matches the same format as if I had used OWAMP or TWAMP.
So for the plugin that I worked on, which is the Speedtest CLI tool, we're using the open source implementation of Ookla's Speedtest command line interface since the Ookla client's version license is proprietary and that doesn't fit with perfSONAR's licensing ethos. So the open source implementation uses a Python package named speedtest-CLI, and that package pretty much gives the user various measurements of their network, like their download speed, their upload speed, their ping, network jitter, etc. In this case, since we're using Speedtest-CLI as a tool to measure throughput, we look at the upload speed that Speedtest measures because that matches up with forward throughput measurement. And some of you know this already, but a throughput test is a measure of how much actual raw data is transferred through the network at a certain time. So when Speedtest is run, it looks at how much data the network is putting through at the time, records it, and then shows it to the user. And so again, the upload speed is the important bit for the Speedtest tool specifically, as that is what would represent the network's throughput in this case. And you could see an example run of the tool on the right, and you could see the resulting throughput measurement at the bottom in megabits per second.
The next plugin that I'll be talking about is the pScheduler response time test. And the primary use of the response time test, officially known as the PS response test, is to check that pScheduler nodes are functioning and get back a response time. And this can be used in troubleshooting and monitoring contexts to make sure that they are running and get back how long they took to respond. In terms of command line arguments, the only required one is the destination or dest that you would like to check. And here, the two types of results are given in the screenshots. For the first, we have pScheduler is in fact running, so we get back a response time. And the second, a message is given saying response time is unavailable because pScheduler is not running. And the tool that goes with PS response time test is the PS timer tool. For the implementation of getting the time in the PS timer tool here in run.py, I subtracted the time before and after running API ping method within pScheduler, which sees if an API server is alive within a given timeout. And a response would mean that it's up, and we would get a corresponding success and response time.
Next plugin is the idle test. It works with two tools, sleep and snooze tool. This method is usually for troubleshooting. It will test whether the infrastructure of multiple hosts works well. There are two required command line arguments, host and duration. In the past, this method only supports one host and cannot work with multiple hosts. However, in some cases, there are several hosts working together to carry out projects. Confirming every host's working status is compulsory and helpful. It will also help programmers to scope the problems of their codes. The way it works, just like there's a room and two hosts sit in the room. Now the two hosts are carrying out a project. If there are some problems during this time, they can stop working together by using the sleep and snooze tool. When they stop working, the system will test their problems during this time. We can test the first host to see if anything is all right, and then the second host. What's more, it can be done without network. Therefore, it provides projects with more convenience. And as you can see in the screenshot, there are two arguments input, the duration and two hosts. It will run successfully when every host works well.
So my test was called Open Ports, and it ran my tool, which is called Nmap Scan. And basically what this plugin does is you give it a host IP or a subnet to scan, and it will list off the accessible ports on each IP and give their status, which will usually be open, closed, or filtered. When a port is open, it means it's actively accepting TCP connections and has an application listening on it. If it's closed, that means it's still accessible, but it doesn't have any applications listening on it. And if it's filtered, that means that there's some firewall or rules in place that aren't allowing the probe packets that are being sent to actually reach the port. So we can't tell if it's open or closed. There's a few others that can come up sometimes if the port can't be reached, but they're pretty uncommon, and you almost always just see open, closed, or filtered. Other than the state, open ports can optionally list additional information about the service listening on each port, like the name, version, OS, and some other information. This makes the scan take a little longer, but can be useful if you want to know the reason behind why a port is open or closed. You can also specify defined port range to scan. By default, the Nmap scan tool will just scan the 1,000 most commonly used ports on a network. But if you know the exact ports you need to scan, you can use this option. And then you can also specify the source IP, which is going to be the IP of the device you're sending the request from. And this is in case there's an interface on your system that you want to use that's different from the one that the tool picks by default. This plugin is going to be useful for those wanting to make sure the security policies they have in place are working as expected, and for ensuring that certain secure ports aren't being left open, as this can be a major vulnerability in some cases. You can see some of the tool's code over on the right. Basically, all it does is invoke Nmap, which is the open source network scanner that we're using for this tool, and then it just parses and returns the results. And then in this slide, there's a couple of examples of what the output might look like. And you can see one of them, the one on the left there, uses the reduced output, and that just shows the port state. And the other one on the right displays the service info along with it. You can also see that while they're both scanning the same subnet, the one on the left shows a status for port 5666, and the one on the right doesn't. And this is because, as you can see in the command line arguments, we're only scanning ports 1 to 5,000 on the right screenshot.
So before we go over the last few plugins, we're going to talk about pSID as they pertain to it. So pSID is an open source Wi-Fi testing tool that's being developed at the University of Michigan. It can provide active metrics. It can also passively monitor the systems for non-nominal behavior. It utilizes RabbitMQ, ELK, and other open source infrastructure to automate installation, archive data, and also visualize it. The main daemon is written in Python and can be run on Raspberry Pi 4s that have Ubuntu installed. Here you can see a high-level overview of how pSID works. So today we're going to be focusing a lot on the first part, which is circled in red, where pSID scans and connects to the BSIDs. So this is a 3-step process, and pSID has to do this to get the data back from the internet. So first you have to locate all the BSIDs for a specific SID. After that, you have to authenticate to each access point through 802.1x authentication. And finally, the access point has to lease you an IP through DHCP. Currently, all 3 of these steps are done natively in the pSID daemon, but we'd like to move that functionality out to perfSONAR. This will allow for cleaner code as well as for others to use the functionality for their own applications. I'm going to hand it off to Daniel, and he's going to talk about scanning for BSSIDs.
So as Maxwell just said, the plugin that I was working on was scanning for the nearby BSSIDs for the given SSID that you specified. And what this comprised of was a test called Wi-Fi BSSID and a tool called BSSID Scanner. Again, as I said earlier, the use of this BSSID scan is it returns a list of all associated BSSIDs and the data associated with that BSSID in JSON format for the given SSID that you've given as an argument. So an example usage case of BSSID scan is if you want to make sure that your SSID is working properly. So let's say, for example, you know that a certain SSID has 12 access points. You can run BSSID scan on this. And if there's less than 12 access points present from BSSID scan, then you know your SSID is not working properly and you're missing a BSSID, and you can then go and troubleshoot that. Specifically for BSSID scan, it takes in 2 command line arguments, and both these are required. The first one is interface, and this is the interface that will be scanned for all the BSSIDs, no matter what SSID that is specified. And then your next command line argument is SSID, and then the list of BSSIDs that are returned are all going to be associated with that SSID. As you can see to the right, this is an example of what the output would look like after BSSID scan is ran. It gets the time that it took to run BSSID scan. And then we list all the BSSIDs. We list the SSID, which in this case was mguessed, and then the signal, the address, frequency, quality, bit rates, encrypted channel, and the mode. And this will list all the BSSIDs associated with that certain SSID. So the main part of the code for BSSID Scanner, for scanning BSSIDs, was BSSID Scanner, which is the tool. And the main part of this was in the run file, and a function called get all BSSIDs would scan the given interface for all BSSIDs, like I stated earlier, and then it returns a list of all BSSIDs and the elapsed time. And then once this happens, the run file will then take that data and use the command line argument of the SSID and find all the BSSIDs associated with that SSID. So you can see in the bottom image, we're calling get all BSSIDs and specifying the interface. So this is the interface that will be scanned on for all the present BSSIDs. And then once that is scanned, we iterate through all those BSSIDs and we find the BSSIDs that are associated with the SSID and add them to a list, and that list is then returned.
So up next, we have the .1x test. The .1x test takes care of the second step by authenticating to an access point using 802.1x authentication. For example, if you had a node that needed to run some tests over the wireless network, you could use this to authenticate to whatever access points are nearby. To use this tool, there's one required argument, the interface. This is just the interface that has wireless interactions on your machine. And then this is also needed because WPA supplicant needs to know which interface to scan on. The rest of the arguments are all for building the WPA supplicant configuration file and are left as optional, so you can build the file as you see fit. So the tool associated with the .1x test is called umichwpa. It utilizes WPA supplicant to do the 802.1x authentication and does this by building the WPA supplicant configuration file and then by building its command line arguments. As you can see in the argv list, WPA supplicant is run with the arguments that are passed in through the test. If the authentication fails, then the tool will return that did not authenticate and has standard output from WPA supplicant fed into the diagnostics. Here's an example run where pScheduler calls up the .1x tests and passes some args into it. After running, it displays whether or not it was authenticated, which here you can see it was, but if not, you can get the error reporting and diagnostics from pScheduler's REST API.
So the DHCP response time plugin is the third and final one coming out of PSID. For this plugin, the test is called DHCP and the tool is called DHClient. The DHCP test plugin takes one optional argument called interface, and you can use this to specify the interface you want to run DHClient on. If you don't provide an interface, the default behavior of DHClient is to search your machine for a list of configured interfaces and run DHClient on the first one it encounters. The tool works by first releasing the current IP address lease on either the specified interface or the default one. And if that release is unsuccessful, the tool will exit with an error. Otherwise, it'll use DH client to request a new IP address from the DHCP server. And full verbose output from DH client for the release and the new IP address lease will be provided in the test's diagnostics for you to look at afterwards. If getting the new IP address lease was successful, the output will include the time that it took to get the new lease, which doesn't include the time to release the current lease, as well as what the new IP address is. And this tool will allow users to make sure that their DHCP servers are working with a consistent response time, which can help troubleshoot issues with overall network performance. So here you can see the output from an example run of the DHCP plugin. And you can see the response time here and the new IP address listed as output. And that is basically it. Those are all of the plugins that we've been developing this summer. So we'd like to end off our presentation today with a couple of acknowledgements. First, we'd like to say thanks to Mark Feit at Internet2 for his great walkthroughs and explanations of pScheduler, and also all of the technical help and guidance he gave us throughout the development process. We'd also like to thank Eric Boyd here at U of M for his mentorship and support, and Rob Thomas for sharing his project management advice and checking in on us throughout the project. Also Katarina Thomas for her feedback and help with putting together these presentations. And finally to the ITS internship planning team for all of the work they've done to make the program possible, and especially all of the logistics that went into this year and last year to make working remotely as productive and comfortable as possible. And at this point, we will take any questions.
All right, well, thanks to all the speakers here. And since you covered a lot of topics here, I think what I may ask Frank to do is go back to probably the start of the slides, just so that people have a memory of each of the plugins in case that they wanted to ask questions about specific ones. I don't know if you have a single slide that has all the names on it. If not, we can kind of just scroll.
I don't think we have that kind of slide.
That's okay. We can just scroll through them a little bit. So what I'll ask is, of course, if people have any specific questions that you want to enter into the chat, please do so now. But we can sort of just walk through each of these quickly. I jotted down a couple. So this, of course, was one that I had the most interest in here. So I'm going to ask an easy question. Is this one able to be integrated into the, what's it called, the batch system for perfSONAR, seeing as though it's sort of a test that we'd like to run on multiple hosts at any given point in time, and we can just sort of use the JSON scripting language to have it be integrated in and just spit out some results for a couple of different hosts?
That sounds like a good question for me, Jason. The answer is yes, because pretty much, I mean, the batch processor can run anything. Can run any valid test any way you want it. Another thing that it can be used with as well is pScheduler, which we haven't talked about in a very long time. But for the case of trying to figure out, for example, where along a path the MTU changes, it would be useful to run pScheduler against that to get a trace of how the packet travels, and then do an MTU measurement to each host along the path.
Okay, well, that sounds great. This is one that that I'll want to use right away, because MTU, I think, is one of the biggest things that we're still getting reports about, people not being able to configure correctly. Not naming any names, but some of you on the call may have had to have Epic debug some of your MTU issues in the not so distant past. And thank you, Daniel, for the link to the slides. I'll make sure that those get posted after the fact. So the next question I had, I don't know if it was the next one, maybe just advance the slides one, Frank. If anybody has any questions on Halfping, I did not have any on this one, but we'll just pause here for a minute in case anybody wants to ask anything. All right, maybe advance it one more. So I did have one on the speed test. So since this integrates in with UCLA, does it also then go and report the results back to UCLA Central when you run the test, or is the CLI that UCLA releases sort of decoupled from the master operation of that tool as a broadband tester?
That's a good question. I think because this is the open source version of it that was on, I believe on GitHub, I don't think it does any sort of like master reporting back to Ookla itself.
Okay.
Yeah.
But it just uses all the same guts as the regular tester that they release for their broadband census.
Right, yeah.
So I guess another question, and I don't know if you want to take this one or Mark may need to help too. Have you sort of compared how it operates against some of the other throughput tools for, just seeing how similar the results are, or if they've been different, or if it's testing something slightly different?
For throughput itself, not really, but I think, yeah, Mark, you might want to comment on that.
Yeah, it's sort of a I guess it's sort of a strange thing because it's Ookla has its own sort of, it has its set of endpoints that you upload to or download from. So we wouldn't necessarily, if we were able to have like an iPer, either a perfSONAR node or an iPer3 server over at the far end, that would be the only way that we would have to actually to kind of do apples to apples comparisons. So this is very much the way this is actually set up is it doesn't really pay any attention to what the destination is. It just uses it uses Ookla to find the closest host and just uses that. So it's not it's sort of not our traditional name both ends type of throughput test, but it is at least useful to be able to run those kind of tests remotely from places.
Okay. I don't know if you've been in contact with the guys at NSRC at the University of Oregon, but I know that there are some instances where there's usually like an MLab host that may be next to, if not on the same physical infrastructure as a perfSONAR host. It would be interesting to see if there are any differences in the reported value, but that probably would take some time to coordinate.
Yeah,
you
that
don't
does
necessarily
sound
know if the paths are always the same, but maybe something for a future project.
Yeah, the big problem with the way the Ookla stuff works is you can actually ask the tool for a list of what the hosts are, but you don't get their IP addresses or anything else like that. Like if there was one at Michigan, it would just be it would just say University of Michigan, Ann Arbor. So there isn't sort of a good way to paw through them and find the right thing.
Yeah, or it gives you like integer IDs that they define themselves.
Okay, and there's no real way to sort of dereference where that actually is.
Yeah, not without wetware.
Okay.
So
all right, well that's interesting. Thanks for clearing that up. Okay, maybe advance it one more, Frank, if you can. So this one, is this going to eventually, is this a standalone or is it going to be sort of integrated in with the troubleshooting routine that does a bunch of different things?
that's a good question. It is a standalone in that you can run it. You could run it on you run it on the command line. You could run it as part of your test mesh, that sort of things. The way I had sort of envisioned it was, in your test mesh, you'd probably have like a kind of a one row test where you have one machine that just goes and checks the health of all the other ones. But this is not any different than any other test, so you can still use it the same way. The troubleshooter, I think the troubleshooter kind of does it manually right now, and we could do something like, we could dump the response time out if we wanted to. So we do have a couple of options for that.
Okay. And Cass is asking in the chat, is there a way to get access to the plugins? I believe there is. It's via the GitHub. If somebody wants to post the instructions into the chat room for how to access things via Git, I think that would be good for everybody.
And these have not been. I mean, these are still at all the interns' GitHubs, and next week we're gonna do pull requests to put them into the the official sources. These will be released with the next feature release, which will probably be 5.0. So we don't have a date set for that. And shoot, there was one other thing I was going to mention about. Oh, yeah, probably within a month or two of that release, we'll have we'll go into beta like we usually do, and then there'll be a separate repository for that you'll be able to just install on a machine if you want to try them out.
Okay. And then a follow-on, have any of the tests that we've talked about so far, or just any of them in the future here, have they been tested through or around firewalls to see if they still function the way you think they're going to work?
Ollie, you want to take that, or should I?
I'm not sure about that one. Yeah, so I think.
Okay.
Yeah, sorry.
Yeah, we haven't. We have not tested them through or around firewalls. There's no reason. Speedtest CLI is Speedtest CLI, of course, is just HTTP, so it'll traverse anything that can pass HTTP. MTU is just a giant UDP packet, so that will, of course, depend on what the firewall passes. In a lot of ways, that's kind of no different than traceroute. And Halfping is just Halfping actually runs ping and picks the results apart. So anything that'll pass that ICMP will it'll work as well.
Okay. Well, maybe the beta test community can help with that then, because I'd be curious, especially about the MTU one. Firewalls don't often like big old UDP packets going through, or ICMP for that matter. So that would be interesting. Okay. If you want to advance one more, Frank. Okay, I did not have any on this one, but we'll wait here in case anybody does have any questions on the idle test.
Just to kind of reiterate what Jing said when she was speaking about this, this is something that we use a lot for troubleshooting, and prior to this, we could only do it on a single host at a time. One thing that I think probably a lot of people don't know is that we have a lot of tests that are kind of single participant that only one pScheduler has to be involved in, and we have others like throughput, where two are involved. The core of pScheduler actually can support as many participants as you want. So you could actually ask 5 machines to do nothing in parallel if you wanted. But the reason the reason that this test was extended this way was, as Jing said, was because we wanted to be able to do the troubleshoot, the command line troubleshoot. We wanted to be able to do it. Right now, we run a simple stream test, which requires a TCP port between the two participants, and we wanted to get rid of that so that we weren't doing anything that was network involved in the middle.
Okay. All right, Casey has a question. How well do the current archive and visualization graphing tools handle interpreting, storing, and visualizing the results from the new plugins? Or how long might it be until most of them are available in the dashboards?
That's a good loaded question. And unfortunately, I don't have a good answer for that. We are in the process of we're in the process of trying to figure out where we're going with that. You should be able to do, for most of these things, there are already things in the dash that are not the sort of the standard 3 or 4 that Mad Dash has been used to doing. So there are provisions in Mad Dash for reporting on those things. So it would just be a matter of figuring out, say what the threshold is. Like if you're doing PS response and you decide that 2 seconds is too much, it's pretty much the same thing. You pull it out of Esmond and you scream if it's above that threshold. So I think that kind of half answers your question, Casey. We will probably, one of the things that the 5.0 series that we're sort of in the early stages of that, but the 5.0 series is going to comprise a complete overhaul of how we do archiving and visualization. So things will very likely change for the more flexible in the next year or so.
Okay. All right, Frank, maybe advance one more.
Actually, Ken had a question I'll answer as well. Ken asked if the tests show results to the CLI, or if they can or will also be sent to the archiver. The answer to that question is yes on both fronts. All these things, every test, you can run at the CLI, and the test plugins all have provisions for turning the results into human readable, into something that's readable by humans. And similarly, any test result you can send through to any archiver. So if you want to send it, to Esmond or through HTTP or by RabbitMQ or anything else like that, it's all just a big blob of JSON.
Okay. All right, so this open ports one, I love this idea, but I can already hear what some of the commentary may be on something like this. So I guess I'll ask the obvious question. Is this going to be something that is turned on and available by default, or is this something that you have to enable?
No, this will be something that you have to explicitly install if you want your system capable of running it. There is already actually another test and tool pair like this called NetReach that determines reachability of hosts on a network, which in a lot of ways is sort of the, I guess you might say, is kind of the pingability counterpart to this. And that that's available in the repository, but you have to install it explicitly if you want the system to be able to use it. And the assumption is that if you're going to if you're going to install it, then you're going to take the precautions to make sure that people can't use it. There was sort of a follow-up question privately to me about that, about whether or not the limits file will let you kind of cut open ports off at the knees. And the answer to that question is yeah. Anything you can accept or reject, tests from any group you want on those same sort of on those same sort of parameters.
Okay, yeah, that was going to be a follow-up for me as well. So good. Okay, if we want to go to the next one. Okay, and then we're into the PSID ones. Actually, I think Jim Warner left. I know he was interested in hearing about PSID stuff, but I don't think he's here anymore. So we'll just pause here if anybody has any questions on the scan. All right, we want to go to the next one. I think all of these are really great ideas. I'm not a campus networking person, but hopefully anybody who does have to maintain Wi-Fi in their campus will get some use out of these. All right, we want to go one more. Yeah, this seems like it would be incredibly useful as well. So when you were testing this one, did you get any interesting data out of it so far? Have you found any problems using something like this?
So in terms of testing, this plugin is kind of still in the beginning stages of that due to some complications with virtual machines and setting up DHCP servers to work effectively on virtual machines. But I will definitely look out for that as I continue with the development.
Okay.
Yeah, I can go ahead.
Oh, nope, I just did okay. Whatever you'd like to add.
Yeah, sure. So Michigan is actually testing this code, or they're starting to. I don't know where they are in the process because it's not something I'm plugged into. But they are actually starting to field test this code with their own systems. What they're using right now is kind of last summer's iteration of pSID, where the code for DHC response time and .1x and the BSID scan was all sort of in a standalone program that was not connected to perfSONAR or pScheduler. So what the interns did this summer was they took those chunks of code, or sometimes in a couple cases rewrote them a little bit, but the interns took those chunks of code and turned them into pScheduler plugins, so that other systems can utilize it. So the stuff that underlies it has been tested a bit, but I don't believe it has been used at an extensive enough scale yet to do troubleshooting and watching out for faults and things like that. But my understanding is that's where Michigan wants to get with this.
Okay, that sounds great. Question on one of them: does the .1x test produce a latency response time result, or just a yes or no, or a true or false?
Ken, are you talking about how long it took to run it, or how long it took to get the result?
The result.
Yeah. Okay. You know what? I don't believe it does, but that would certainly be something that's easy enough to add.
It does measure it. It just isn't displayed to the end command line.
Oh, well, we should
screen for
fix
human
that then.
readable, but it'll be added in.
There you go, feature request accepted. All right, want to advance it one more, Frank?
I think that's the last one.
Oh, it was the last one. Okay. And then the hypnotic bunnies. All right. Well, I don't think that the community can thank all of the interns enough here. Still churning out good software. And I guess I'll ask one last question here, similar to what I asked last time. Hopefully everybody, of course, learned something and got something out of the summer. If anybody wants to share any particular insight or real aha moment that you got out of this experience of developing some open source code for the research community, I guess I'll just leave it as an open mic there if there's any of the students that want to say anything else about it. Nope, everybody's just ready to be done.
I was just gonna say, I tended to, or at the very beginning, I overthought what I had to do to get like the throughput measurement from the Speedtest CLI tool. And so it took me a while for it to click where I was like, I don't really need to do much with this. I just need to pass in a couple of arguments into the CLI tool and then I get the result I want. But I guess I just had to get over that like mental hurdle of like, I'm not experienced with perfSONAR. I probably don't know what I'm doing, that kind of thing. So
Yeah, that's a great observation. You know, even if you can record that sort of experience so that future students, either at Michigan or beyond, can understand how that works, that'd probably be a valuable thing for the development process in the future.
yeah.
So that is always a hard thing for people who just are thrown into a big project and expected to swim right away. All right, any others that want to share anything in particular? All right, so I'll throw it over to Mark if there's anything else you want to add before we wrap up for today on this year's program of development.
Sure, thanks, Jason. I'd like to thank the interns for doing a wonderful job on all this. It's been a really great summer working with all of you. For everyone for the community who's plugged in here today, one of the things that happened this summer was that our list of plugins that we want to do has actually been chopped down to nearly nothing. So what that means is that for the future, we will probably need some ideas for more projects. A lot of the stuff that we do comes from ideas from the community. So if there are things that you measure that that perfSONAR is not capable of measuring right now, if there are tools available that that get the measurement for you, that have things like machine readable results that we could turn into plugins, then by all means, please suggest them. You can write tickets against pScheduler if you want, because that's sort of our to-do list. Personally, I'm really interested. Somebody mentioned IPv6 test plugins, and there are a couple of things I think in the pipeline for that that the interns are not working on this year. But one of the things that I'm actually really interested in is layer 2, which is not something we have tested historically. But if there are tools available that people are using, please drop us a line and let's talk about it, because that's definitely someplace that the perfSONAR could expand. So, and with that, layer 2 traceroute, Ken says, perfect. So with that, I will turn it back to you, Jason. And once again, thanks everybody for coming, and thanks to the interns.
Ken may be feeling facetious there. You know, that's a bit of a fool's errand, but hey, if you can get it, that'd be great. I guess I'd throw in a couple of ideas here. You know, there's also been an increased emphasis within the community on security for routing protocols and just security in general. So I know that there's always little tests that would be valuable to have with regards to that. You know, are you compliant with various standards and things like that? You know, I wouldn't know how to design such a thing, but that's an area worth probably investigating if you want to talk with the Internet 2 routing working group or any of the various security working groups that are looking at things in that space. You know, those would always be valuable and would probably help extend perfSONAR into a community that doesn't traditionally use it, you know, a little bit beyond just network measurement, but also reporting on status and capability and stuff like that. And then I know that the campus use cases usually revolve around things like Wi-Fi, and there's been some good inroads there, but thinking more about what a typical campus engineer would need in their toolkit to be able to just do basic things. So, and I echo the V6 testing, you know, even though everybody has a lot of V6 tools, maybe having some form of umbrella to do a battery of things would be good in that realm. All right, well, I think we've exhausted all the questions. So thanks again to all the Michigan interns and to Mark for the talk today. We're going to be on a 1 week pause, so no talk next week, but we're going to pick up the week after with a talk from Phil Hippensteel at Penn State talking a little bit about video standards. So hope everybody has a good weekend, and we'll talk to y'all soon.